They made a new AI agent system that generates posters, so converts your or any research paper into a poster. So this is what it looks like. If we take some research paper, you see this is what it looks like. It puts in images, text. I can zoom in even more, so you can see the poster generated here. And you can see this poster as well. So it has 3 columns. It puts these images, calculates text size, how to put text and everything. I'll show you some more. So you see here, just this one on the right side. You see this one and this one. And now we will go step by step and understand how we generate colors, how the agent works itself. So we have different agents, layout agent, curator, designing, director. We have a layout which it is using. You can find the code here. And in the GitHub, you see how to run the code and use it yourself. Now let's go step by step and understand how these agents work if you want to code, understand, or research this yourself, or improve this one. The core problem. Researchers often need to create posters for academic conferences. This is time-consuming and difficult task because it requires not only summarizing complex research, but also applying design skills to make the poster visually appealing and easy to read. Existing tools often fail in one of the key areas, aesthetics and design. They might pull the right content, but the final poster looks cluttered, ugly, has overlapping elements, and requires a lot of manual fixing before it's usable. The proposed solution, PosterGen. The authors propose a new system called PosterGen. The key idea is to create an automated system that thinks and works like a team of professional designers. Instead of using one single massive AI model to do everything, PosterGen uses a multi-agent framework. This means it has several specialized AI agents, each with a specific job, that collaborate to build the poster. This approach is aesthetics aware, meaning the principles of good design are built directly into each agent's logic. The foundation core design principles. Before building the agents, the authors identify 4 core principles of effective poster design, which PosterGen is built to follow. Narrative. A good poster tells the story. PosterGen uses the and, but, therefore, ABT structure. And here's the established context or background, but here's the problem or gap in knowledge. Therefore, here's our solution and what we found. Layout structure. To ensure a natural reading flow, PosterGen uses a strict 3-column grid. This layout avoids chaos and places the most important visual anchor at eye level in the center column. It also heavily utilizes white space to separate elements and reduce clutter. Color design. The system uses a limited and harmonious color palette. It extracts a theme color, often from the author's university logo, and generates a monochromatic scheme for it. A high contrast accent color is used sparingly to highlight key terms, ensuring readability. Typography design. Clear fonts sans serif are used to create a visual hierarchy. Different sizes are used for the title, headings, and body text. Semantic hierarchy is created using bold, italics, and the accent color to emphasize important words. The multi-agent workflow in action. A PosterGen's process is divided into stages, with different agents handling each stage. This mirrors a real-life design workflow. Parser and Curator agent, a content and storyboard. Parser agent, this is the first agent. It takes the research PDF as input. It extracts all the raw text and images. It distills the paper's core message into the ABT narrative structure. It organizes the text into logical sections and classifies all images by their function, key visual, main result, method, workflow. Curator agent, this is a creative director. It takes the structured content from the parser. It designs a storyboard, deciding which content goes into which of the 3 columns, following the ABT narrative. It enforces a limit of 5 to 8 sections to prevent the poster from becoming too crowded. Layout agent. spatial arrangement. This agent takes conceptual storyboard from the Curator and makes it concrete. Calculates precise coordinates x, y, and dimensions with height for every single text box and image on the poster canvas. A key technical challenge it solves is accurately estimating the height of the text box, which is difficult in the programming library used, Python PPTX. It uses a clever binary search algorithm 1 in the paper, to find the perfect height without the text shrinking or overflowing. It uses a CCS-like box model to precisely control the white space, margins and padding around every element, ensuring a clean, balanced look. And then styling agents applying aesthetics. Color agent. This agent creates and applies the color scheme. It analyzes the author's affiliation logo to find a primary theme color, then generates a harmonious palette based on it. Font agent. This agent handles all the typography. It uses an LLM to identify important keywords in the text. Then it applies different styles, font size, bolding, italics, accent colors, to create a clear visual and semantic hierarchy. Renderer, final production. This final module takes all the metadata, content, coordinates, sizes, color fonts from the previous agent. It uses the Python PPTX library to programmatically generate a final PPTX file. Finally, it converts this file into a high-resolution PNG image ready for the user. To evaluate these generated posters, the authors created a detailed scoring rubric, Table 1, that assesses both content fidelity and design quality. Instead of relying only on human judges, they use powerful vision language model as an expert judge. They gave the VLM the rubric and the generated posters and asked it to score them. And if you combine a GPT-4o image generator to their poster agent is better if you just give entire paper to either of these.